Feature selection for machine learning technical analysis patterns. In this video, through various cases and examples, you will learn about identifying and auxiliary data, about features and meta-features, culminating in a comprehensive understanding of features with a big picture guide. First, let's start by showing the image of the pipeline to locate where the topic of features is situated. As you can see in the image provided, feature engineering, feature selection and feature importance is a critical part of the data pre-processing phase. Now, imagine a family, the Johansons, who want to explore the possibility of university education for their children. To do this, they will analyze their wealth. 1. Apart from their house in Connecticut, they have a small apartment they rent out in Manhattan. Real estate makes up 25% of their wealth. 2. They also have an equivalent amount, 25% in short-term deposits in 2 banks, representing the money they save each month. The Johansons are cautious, so while they are not preppers, they keep 10% of their wealth in gold for financial security. 3. Sarah Johanson invested 1% of the family's wealth in her brother-in-law's bakery when he faced a rough patch after the 2008 crisis. 4. The rest of their wealth is invested in American blue chips like Amazon, Nvidia, and Apple, as well as in Volkswagen, a German car manufacturer, and Sony, a Japanese company. When considering how each of these investments can help pay for their children's university education, they won't treat the liquid money in the bank the same as the illiquid investment in the brother-in-law's bakery. Similarly, the risk of fluctuation in the value of their stocks will differ from that of their real estate properties. Therefore, each asset influences with its own pros and cons and in its own way. And this is exactly the idea behind features. Just as each asset affects the Johanson family's financial planning differently, features influence a model's predictions in various ways, each contributing uniquely to the overall performance of the model. Understanding the importance and impact of each feature is crucial in building a reliable and accurate predictive model. Importance of challenging assumptions. Let's consider an important concept. As technical analysts, and practically as human beings, we tend to have preconceived notions about initial data. But what if our assumptions are wrong? Suppose our job is to give personal loans, and we want a good model to predict repayment. We might think age, annual income, and credit history are important, while the floor of their apartment or pet ownership is irrelevant. But what if that assumption is incorrect? Similarly, there's a famous anecdote about Van Halen's concert contracts. The band included a clause requiring a bowl of M&Ms with all the brown ones removed. Although it might seem like an eccentric request, this wasn't just a trivial demand. Van Halen used more complex and heavier equipment than usual, and needed superior safety measures to prevent stage collapses and other issues. If they arrived and found no bowl of M&Ms, they knew they had to inspect everything thoroughly. If there was a bowl with M&Ms but some brown ones, it indicated that the promoters weren't meticulous enough, warranting a detailed review. If the bowl contained no brown M&Ms, it showed that the promoters were meticulous, and only a superficial check was needed. Just as a promoter might wrongly assume that the M&Ms were an irrelevant issue in the contract when they were crucial, we might be assuming certain factors are irrelevant when they are not. Technical data and feature selection. Now, let's look at this table with technical data. We want to predict if a stock will rise or fall tomorrow. For this, it is useful to employ the simple moving average, the RSI, and an exponential moving average. We might think that the number of days a stock has been below the 3 or 5 period moving average is absolutely irrelevant. But what if we are making an incorrect assumption? Feature selection and technical analysis. 1. Use machine learning techniques to objectively identify important variables before fitting any model. 2. Use machine learning techniques to separate the specification search from the variable search. That means machine learning techniques can help you isolate important variables first and then fit them into the appropriate model. We don't want the algorithm to work as a black box. Instead, we, as researchers and technical analysts, need to learn alongside it. This approach ensures that we understand why certain features are chosen and how they contribute to the model's performance. Big picture of data processing. Finally, let's summarize the last image, which shows the big picture of data processing. Here's a brief overview of the steps. 1. Exploratory Data Analysis, EDA. Perform descriptive statistics to understand data distribution. Visualize data to identify patterns, trends, and anomalies, and understand relationships between variables. 2. Feature engineering. Transform raw data into meaningful features that can improve the performance of machine learning models. For example, creating technical indicators such as RSI or moving averages from the original open, high, low, and closed data is a way of feature engineering. 3. Feature selection. Apply techniques to reduce dimensionality and eliminate irrelevant or redundant features to enhance model performance and interpretability. We can reduce dimensionality hybridizing indicators, like several period moving averages, into a single one. 4. Feature importance. Evaluate the significance of selected features using methods like random forest or linear regression to determine which features have the most impact on the model's predictions. This comprehensive guide will help you understand the critical aspects of feature selection, engineering, and importance in machine learning technical analysis patterns.